Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is ignition testing. We're going to talk about operation, diagnostics, and how do we test ignition systems even today. So first off, we'll talk about why ignition system testing. Why are we here? Why are we talking about this to begin with? Because I don't know if maybe it seems like it might have fallen out of fashion over the last few years for ignition system testing, but I think you'll agree, at least by the end of this, that maybe it might be something you want to look into. So talk about how ignition systems are set up. We'll go through an overview of how it's set up, so that way we can learn our approach to testing it. Ignition system tests and tools. What do I need in order to test, and what kind of tests can I do? And then we'll go through some ignition waveform analysis as well. So we'll take a look at firing line, spark line. What does it mean when the spark line goes down? What does it mean when it goes up? What does a high firing line mean, etc. And then we'll go through a live on-tool walkthrough using the built-in ignition features in the tool. So first off, why ignition system testing? Let's think about a few little questions here. So has OBD2 eliminated the need to test ignition system? OBD2 gives us a code and it tells us exactly what's wrong with the car, and we never have any sort of problem there. I can't say that with a straight face, right? I think we've all been there where, the code really isn't, it's just the start of our diagnosis. It's really not it's not as perfect as we all would have hoped it would have been. So of course we do need to do further testing when it comes to OBD2. And that means it hasn't eliminated our need to test ignition systems, right? How about newer ignition system designs? How about coil on plug vehicles? Those never have problems, right? We never have to test ignition systems on those coil on plug vehicles, right? I think you'll agree that you've worked on a few of those ignition systems and the coil on plugs on there, and more than likely you've had at least one or two fail in your time, right? So guess that doesn't solve our problem, right? Maybe we still do need to test those ignition systems too. And then how do we verify ignition system performance when we're diagnosing a drivability complaint? So if we think about drivability problem, it could be a fuel issue, could be some sort of a mechanical issue like compression or airflow, or hey, it could be an ignition problem, right? How do we verify that the ignition system itself is working properly? Well, we need to test it, right? So let's take a look at a little case study here. This is a vehicle that came in and it was a misfire, right? A PL300 code. Random misfire there, and they could feel it in the seat. It's the every once in a while, feel the seat vibrate a little bit, maybe, or when you're driving down the road, maybe you feel it skip every once in a while. So the tech decided, well, let's get some more information about this. Let's hook up to the ignition system and see what the ignition system can tell us, because that could be one of the issues. And what we're looking at here is what we call a raster pattern. As we talk through this information in this session, we'll talk about all of these different things and what they mean. But what a raster pattern is it's all of the cylinders represented on the screen at the same time, so we can compare them time-wise. So they're all lined up on the left-hand side with the firing line, right? So that is where the spark jumps across the gap in the spark plug. And then each of these flat lines would be the spark occurring in each of the cylinders. Now, if you were to look at this, do you see anything that jumps out at you as something that could be wrong? I know when I look at it, I don't really see anything that jumps out at me that could be wrong. And this was taken at an idle. And the technician doing this test took a look at it and they decided, well, I don't really see anything going wrong here. They all look fairly even, fairly similar in the way that they're shaped. There's small differences, but for the most part, by and large, looks like everything's working the way it should. So the tech decided, well, maybe we need to change the driving conditions, change the engine conditions. So they decided to do a brake torque. You know, you put on, smash the brake, smash the gas, put it in drive, get that engine to torque up real good and put it under a good load and see what happens. So this pattern is what came of it. Now, whether you understand looking at this or not, and maybe you do, maybe you don't, but I think we could all agree that that second one from the bottom, that isn't right, right? That does not look like all of the other cylinders. All right, so this right here, this spark line where it goes up in a large hook there at the end, this indicates a lean condition in the cylinder. So we'll talk through that as we go through, but that indicates a lean condition because the leaner the mixture is, the higher the voltage will be. So if we look here, it looks like it was probably pretty good to start with the burn, and then it slowly got more and more lean, and then it got very lean at the end. So it probably just ran out of fuel to burn at this point, and then it just kind of off to the races at that point. And then when the burn is over, it goes back and it recovers, and then it starts over again. So on this one cylinder, this was cylinder 5, they detected by doing this test that, hey, there's a lean condition on this cylinder. So it wasn't even an ignition problem. It was actually a fuel delivery problem. And it ended up being a bad fuel injector on that one cylinder. It wasn't spraying enough fuel under a load. So it doesn't even have to be an ignition problem that you can find while doing an ignition test. All right. So in this case, it was a fuel problem. So then we'll talk through this as we go. All right, let's talk about how an ignition system is set up. Really, you can divide an ignition system into 2 halves. We have a primary circuit and we have our secondary circuit. And really the easiest way to split it in half is right down the middle of the ignition coil, because we have both a primary coil and a secondary coil inside the ignition coil as well. So pretty much the primary circuit is going to be anything attached to the primary coil or that controls the coil. So think battery, right? That's where our voltage starts. Alternator, ignition switch, ignition control module, cam sensors, crank sensors, pickup coil if it has it, any sort of triggering device, also the ECM depending on how it's set up. Right, so all of that is considered primary side of the ignition system. Then we get to the secondary side, that'd be anywhere in the secondary coil all the way out through the spark plug gap. So in this case, this is a conventional ignition system. And we have our secondary coil here. It goes down the coil wire into the center tower, goes out through the rotor to one of the spark plug wires, down the spark plug wire, and to the spark plug. Now, in that case, there's many different points of failure, a lot more complex of a system. But on a coil on plug vehicle, it'd be pretty much the same here. We have a secondary coil. Then you'd have maybe that contact spring in there that allows a contact with the plug, and then it just goes out through the plug that way. Right? So it's less complex, but it can still have problems, right? So we still need to be able to test it. That's why if you've ever looked in any of our testers, you see primary side or secondary side test. That's what we're testing. We're testing it before it sparks or after it sparks or while it's sparking. And that brings us to mutual induction. This is the essence of how an ignition coil works. And what that is a transfer of energy from one coil to another when they're placed close to each other. The coil connected to a voltage source is going to be called the primary winding. And then a second coil connected to another circuit or the output side would be the secondary winding. So we see we have a cross section of a coil here. And we have this, usually it's iron magnet type material in the middle, some sort of an iron core. And on this side of the iron, it will have a smaller number of turns, the primary side. So we see we have 10 turns on that winding. And then our secondary winding has 1,000 turns in this case. So the difference between 10 turns and 1,000 turns, that's 100 to 1 difference, right? 10 times 100 gives us 1,000. So due to that, when it transfers the energy over, we'll have some math go on, right? We'll have some math occur. So we have 14 volts in, 14 amps in, gives us 196 watts of energy. When it transfers, the energy stays the same, 196 watts total. the volts go up by a factor of 100 because it's 100 to 1. So 14 volts gives us 1400 volts out, and then the amperage goes down by that factor of 100. So we have 14 hundredths of an amp. So this is how we get 10, 20, 30,000 volts out of a coil. It's just the difference in windings in between, because generally on most automobiles, you're going to have maybe 14 volts coming in and maybe up to 14, 15 amps coming in. Probably not much more than that because the alternator puts out about 14 or so volts. So starts charging there, and then because of that step up, we have many more windings on the secondary side that gives us that extra voltage. So here's a little animation that kind of describes how it works. It's a very simplified setup. So we have the switch. When the switch is thrown and completes the circuit, we have electricity going into the primary side of the coil. That's dwell. It will generate a magnetic field. When we release that energy, release the electricity, that magnetic field collapses and it goes over to that secondary coil, which gives us enough voltage to cross that larger gap on the other side. Right? So that is a super simplified version of how that works, but that's how it works. Using this mutual induction principle means that whatever affects one side also affects the other side. So if I have a problem in the combustion chamber, I'll be able to see it on the primary and the secondary side. So here's an example graphic here. Top line, green line, that is a secondary ignition on a cylinder. And we can see we have dwell right here. We have the firing line right there where it jumps the spark plug gap. We have the spark occurring here. It looks like it got a little lean in this one as well. It's going up a little at the end. And then we have our coil oscillations there at the end. So that's secondary. So that'd be with a probe on maybe an ignition coil wire, right? And then we have our primary side. So this would be tapping into the primary side of the coil. So we have the dwell, we have the firing line, we have the spark line. Everything lines up time-wise, right? If you drew vertical lines through all of these, everything lines up. Now there's more detail in the secondary because we're dealing with larger voltage swings, so it can detect that up and down a lot more. Much smaller voltage swings on that primary side, so we can see the difference here. It does curve up at the end there, so it would be a lean condition, right? Now, where might I want to apply this information? So let's say, for example, a good example is like a Ford Edge. Working on one of those before, and has a transverse mounted engine. The 3 coils in the front, super easy to get to. I could do secondary ignition on that, no problem. Just put the flags right on top. But the 3 coils in the back, well, those are under a big plenum, and it's also really close to the firewall. So in that case, you'd have a really difficult time getting any flags or pickups back there. So in that case, you'd probably want to use primary side testing in that case, so you wouldn't have to mess around with taking the engine apart to get back there. So test whichever is easiest to get to. So once we've decided on whether we're going to test primary or secondary, what do I need in order to test the ignition system? Well, first off, we need a scope capable of ignition system testing. So any of our tools that have a scope in them are able to test at least single cylinder ignition. So Veris, Zeus, Verdict, Vantage, Modus, Triton. Any of those tools will be able to test secondary ignition. The 2-channel tools are able to test a single cylinder, and then the 4-channel tools also have a built-in ignition scope inside them. So the Veris and the Zeus at this time would have an ignition scope built in. What else do we need after we have a tool that can perform this function? What else do we need? Well, we need some adapters. And so at the bare minimum, you need this adapter cable right here. This end plugs into the tool, so that'd be whatever channel we're using. That's the ground. And then you see there is a male, what we call an RCA plug on the end. So all of the adapters have a female RCA plug on them. So we can simply plug it in there and then attach it to the tool. This is an inductive pickup probe, or a capacitor probe, sorry. This is designed for using on vehicles with spark plug wire. This end of the adapter plugs into the other end there. But we have found, as time goes on, you can actually unscrew the end of this, take that off, and then you end up with a little metal nub at the end. And that little metal nub can be put on top of a coil, and you can see on a coil on plug vehicle, measure those coils as well, just using it like a stick or a wand. So kind of a nice little dual use. You may even have one of those in your toolbox. We've had these around for a very long time, and they still work with the tools we have. Also an inductive sync probe. This is good for doing multiple cylinders at the same time. So this would plug in on the top of a Varus or a Zeus, that funny looking connector on the top of the tool. That's what goes in there. So we would use that around a spark plug wire, or you could also use it on a coil on plug vehicle for the trigger for the coil. You can put it around that trigger wire as well, and that will also tells the tool where number 1 cylinder is. So it knows the firing order, needs to know where number 1 is. We also have a multitude of other adapters we could use for coil on plug testing. This first one here is a wand or a stick pickup. So you could touch the top of a coil and it would work like that. Or if you had an inline 4-cylinder or 2 banks on a 6-cylinder, 2 banks on an 8-cylinder, as long as I can get it across the top of all the coils in line, I can measure all the coils at the same time. The most economical way to get into secondary ignition testing would have to be these flag pickups right here. So they're available in singles, doubles, and triples. And then they have a male end and a male end and a female end, right? So we can daisy chain them together. If you were here at the very beginning, we showed a little video on how to hook these up. So male end, female end, and then you can just daisy chain them together to get however many flags you need. We also have 11 different part numbers of vehicle-specific coil on plug adapters. So anywhere from a Ford or a Lexus or a Volkswagen. There's also the most common one, or at least the most popular one, I think, is the COP1. That's for the Ford coils that are round and they have the little flat spot on the side where the plug goes in. Clips right over that flat spot and allows you to read the coil from there. There's also one for, say, like GM HEI. So if you have any of those, you could use that as well. Get right to the coil right in the top of the cap. Multiple different versions for multiple different vehicles. There's a couple that are even adjustable, so they fit multiple vehicles. So definitely something to check out if you're interested. And then we also have this SIA 2000. You may have seen this before. It's been around for a while. It was originally designed for what we call waste spark vehicles. So on a waste spark vehicle, if we think back, let's say late 80s, early 90s, mid 90s, GM vehicles, many of those cars had these waste spark systems. So those coil packs with the 2 towers that clipped onto the ignition control module there. And they'd fire both towers at the same time. So one would fire on the ignition stroke, one fires on the exhaust stroke of a companion cylinder. So in that case, one side is getting a negative polarity, the other side is a positive polarity. So the back of this tool is actually marked with a plus and a minus. So you plug in the negative side to the negative side, the positive side to the positive side, and you can see all cylinders on the screen at the same time when they fire. Newer versions of these also come with 2 umbilicals that'll plug in on one side, and they have 4 wires each, and those are male RCA adapters. So you could use up to 8 of those coil on plug individual flag pickups, if you will, with this tool as well. So it kind of gives, once again, another dual expanded use on that. So that is available. Once I have all of my adapters and my tools ready, how will I go about approaching testing this? Well, there's 4 main patterns that we would be using when we're testing ignition. Now, the one that anyone can do, as long as they have a tool with a scope, would be single cylinder ignition, right? So we have the, this allows us to see 1 cylinder, maybe 1.5, 2 cylinders, depending on how we have it set up. But that's really used for voltage comparison. How high is my firing line? How's my spark line look? We can take a look at the pattern using that single cylinder. Then we get over here on the right-hand side is what we call a parade pattern. So this allows us to connect to all cylinders at once. You feed them all into the tool, and then we do a few setup functions, and then you'll be able to see all of the firing events on the engine at the same time, on the screen at the same time. So that way you can compare across the cylinders, how are they working. So it looks like this one, this one, this one, most of those are even. This one's much higher. This one's much lower. What would cause that? Could be a few different issues. We'll talk about it in a little bit, but what is the different cylinder? Where is my oddball cylinder? And that's the one that you'd want to look at. So it allows you to test that way and compare that way. Then we have the raster pattern we saw at the very beginning of the presentation, right? So that's stacking all of the cylinders one on top of each other. So we can see, are the burn times fairly equal? Is one going very high at the end, like that example at the beginning where it shows a lean condition? So we can see the differences between the cylinders. And then there's also a superimposed pattern as well. That sets all of those raster patterns on top of each other this way. So we can see, is the engine running fairly smoothly, or are the cylinders fairly similar in how they're running, or do we have any outliers there? The raster, the superimposed, and the parade are available on the Ignition scope tools, so on the Veris and the Zeus. As I said, everyone else can do the single cylinder. So once I decided how to test it, what tests can I do? First off, we have a primary voltage test, and that is very simple because we don't even need any adapters. We just need maybe a back probe in order to back probe at the coil or the coil connector. So in this case, the coil unplugged vehicle, and we have a back probe going in there, and we are going to test it on the voltage supply side to see the primary voltage going in. Now, in this vehicle, it works a little bit differently than some other vehicles. So when dwell starts on this, the voltage starts to go down. And then when it fires, it goes up. So it actually, the voltage starts to drop because it's storing it in the coil, and then it fires. Right? And then we don't see the spark line there. If we were to overlay it with the secondary side, here's my secondary on the bottom. So there's where dwell starts. There's where dwell starts. There's my dwell. And then there's my firing line there. There's my firing line there. And then we can see all of that occurring. So that's primary. Secondary side, primary current test would be the second test that we're going to do. So you hook a low amps probe to the ignition coil feed circuit, so the power circuit again, same wire we used before for the primary side. You hook it in there around the wire, and you will see the coil current going into the coil. So this is an example of a known good primary current ramp test. So we see the current is 0, and then when the dwell starts, we should see a nice smooth ramp come up like this. If it went up sharply and then over, that would indicate a problem inside the coil, inside the windings, and the primary windings could be a problem, and they're high resistance that amperage needs to overcome. In this case, this is what we call a current limited coil. So it looks like at around about 12 amps, it just levels off. If it wasn't current limited, it would come up and then come down like a triangle. It'd have a sharp point at the top. We overlay that with the secondary side. We see dwell starts, amperage rises. Then it levels off, and then when the coil fires, all the amperage goes away, and we should see it line up like that. Here's an example of a bad current test on a vehicle. Remember how I said it goes up sharply and then over? So this had bad primary windings in the coil, and it came up very sharply and then over. Now, this is a slightly different design than what we've been looking at before, too. So this is what we call a MultiStrike ignition. So it will come up, it will have one main firing event, and then has multiple smaller firing events as it dissipates the energy inside the coil. Usually it's around about idle, low part throttle. Usually as soon as you get off idle, just goes to a single ignition event. This is on a BMW. Fords have this system as well. I'm sure other manufacturers also use that type of system on some of their vehicles. So if you see something like this, don't be worried that there's something might be wrong with the vehicle. It's probably normal in that case. Then if we replace that coil, here's what a known good on this car would look like. So once again, it's a BMW. Here's a normal coil ramp. In this case, it's not limited, so it just goes up until it fires. And then since we have extra resistance inside the coil, because we have all the extra voltage, you will see on the successive sparks where you'll have that sharp upward ramp, and then it kind of looks normal. You see how it's sloping down here a little bit too as the energy dissipates throughout the coil. So you can see all the differences in the pattern that way. So now let's look at ignition control signal, right? So in some cases, you have a coil where it has an internal ignition control module. And in that case, the ECM generally will send out some sort of a signal to tell it to turn on. So in this case, we'll hook up to the control signal there. And then you see, in this case, it's a 5-volt square wave. Many times it's a 5-volt square wave. Right? So when the square wave turns on, that's where dwell starts. Where the square wave turns off, that's where it fires. If we were to line it up with the secondary, once again, dwell starts there. As the square wave comes on, square wave goes across, comes down when it fires. All right, so we can see how everything relates over time. And then we have secondary voltage. We're going to spend a bit of time on this section because there's many different things we can tell about that secondary pattern. So we want to connect to the spark plug or the coil wire if it has those, or directly on the coil if we have a coil unplugged vehicle. So in this case, we have a flag. We put it on top of the coil, and there's our secondary ignition pattern there. All right, so we can see that dwell pattern. We can see the firing line. We can see the spark line. And that brings us to a known good pattern. So this is known good out of a textbook. What a common ignition event looks like on the screen. So we've talked about it a little bit already, but we have dwell here. So you'll have these oscillations here as it's starting to charge. Things are bouncing around in there as it starts charging up. And then when it's time to fire, we have this tall firing line. So the firing line represents the voltage needed to cross the spark plug gap and get that spark going. So that's going to take a lot more energy to ionize that gap than it does to actually keep the spark going. So when you get to the spark line, you'll have a big drop off here, and then you'll see the spark line come out considerably lower. Then in this case, depending on how efficient the coil is, you may see these coil oscillations at the end. So these are the ups and downs right here, and that is basically the energy dissipating out of the coil. So you may have heard the term before, wringing out a coil, like you wring out a towel, you wring out the water. In this case, we're wringing out the electricity inside the coil. So we have these oscillations. If the coil is more efficient and uses most of its energy, you won't see one or any of these. All right, and then it goes out, waits for a little bit, and then when dwell starts again, we see the oscillations. That brings us back to the left-hand side. So let's talk about diagnosing this pattern. So we have firing line first, because that's the first thing in the pattern, right? So the voltage of the firing line will be dependent on conditions inside the cylinder, also conditions of the equipment. High firing line voltage can be caused by wide spark plug gaps due to the distance it has to travel, right? Lean air-fuel mixtures, because it has less hydrocarbons to burn, so lean equals high voltage. High cylinder pressures, we're talking down at the molecule level, where the molecules are pushed tightly together due to compression. Higher cylinder pressures require higher voltage. And then retarded ignition timing, because of where it is in the compression cycle of the engine there. So these can cause it. Also mechanical, like say you had high resistance in spark plug wire, high resistance in a cap and rotor, depending on how the vehicle is equipped. That could cause a high firing line as well. You want to check the firing line either as a single cylinder, which we can all do, or with other cylinders for comparison. Even if you were doing a single cylinder test, you could test one cylinder at a time and just note where each of the events were. Typical tests we could do are a cranking test, a cruise test where we hold it at about 2,500 RPM, and then a wide open throttle snap test. So here's an example of a cranking test on a 4-cylinder. Right, and this was wide open throttle because this vehicle had a fuel cut. We didn't want it to start. So if we hold it at wide open throttle, we go into fuel cut, we don't start. So it looks like about 10,000 volts on each. Pretty good lines here where the spark is occurring. There is not a lot of turbulence because we don't have a lot of burning because there's no fuel in the cylinder right there. So that is just a regular wide open throttle test cranking. Here's a test on the same vehicle. And we captured these patterns during a tune-up. So this had about 150,000 miles on its spark plugs. So before we replaced the last spark plug, we wanted to say, well, what would be the difference? Where would we see a difference here? So here's your worn out spark plug right there. We can see the firing line is considerably higher because it had a larger gap that it had to cross. Right. So if you see it, there's my outlier. There's the cylinder I would need to look at. Right. The other cylinders look fairly the same with each other. Here's an example on a different vehicle with a bad coil. So this is a 6-cylinder vehicle with a single coil, cap and rotor. So you can see how it's trying to put out enough voltage to cross that gap, but we don't see any sparks occurring there at all. It's just a very weak coil. It's not able to put out nearly enough voltage to cross that gap. Back to that 4-cylinder vehicle with the tune-up. Here's a cruise test. So we went from cranking, and then you could do an idle test, and then we could do a cruise test where we rev it up to 2,500 and hold it there. Due to the timing advancing, the firing lines go down. So we were up at 10, now we're down at about 3,000, maybe 4,000. Right, so it comes down quite a bit, and then we start to see more turbulence in our spark lines as well. So why do we get turbulence? Due to the swirl inside the cylinder, right? Due to how everything's air-fuel is mixing and atomization and all that. It's not exactly a perfectly even mixture across the board everywhere in there. So as it gets a little bit richer, a little bit leaner, a little bit richer, a little bit leaner, the voltages go up and down. Right? And then here's a wide open throttle snap test. So you take it and you snap the throttle all the way to wide open. You let it rev way up, and you see what the cylinders do. So now my spark line, my firing lines go up, and my spark lines are shorter, much shorter. And they also have considerably more turbulence because if you think at 4,000, 5,000 RPM, wherever this happened to be, you would see quite a bit more turbulence inside that cylinder. and it's spinning much faster, so we don't have nearly as much time to have a spark happen. All right, so that's what we can see in there. So this is on a known good vehicle. And that brings me to the spark line. So the length and shape of the spark line will be affected by whatever's going on inside the combustion chamber as well, rich and lean mixtures, etc. Spark line should jump out, be fairly horizontal from the firing line, and show some turbulence, that ups and downs that we talked about. The spark line can be anywhere from 0.85 to 2.5 milliseconds in length. And lean mixtures, once again, increase voltage, rich mixtures decrease voltage. So just remember, lean goes up, rich goes down. So here's an example on a known good vehicle. It's a different vehicle. This was had spark plug wires. So we had it around 1 spark plug wire. And you can see it's nice and straight, nice and horizontal. This was captured at idle. So very little ups and downs here. It was very smooth running. And we see us fairly level. And we have a couple little coil oscillations there. And this is the same vehicle, same cylinder, and we introduced a lean condition in there. So you can see it goes through. And it is pretty good here. It was level, but then it goes up towards the middle and towards the end. So we have these additional coil oscillations there because it just wasn't able to burn enough fuel. The vehicle almost stalled when we did this. So level and then leaned out. And then here's back to the vehicle with the tune-up. So before we did a tune-up, we wanted to take a look at the pattern. So this is actually a rich condition. So you can see there's my firing line, there's my spark line comes down, and then it levels off right there. So we have that little bump before it ends. Right, so that is a rich condition. And then this one is the same vehicle, same cylinder after we replace the plugs. We can see that it is pretty straight. We don't have that bump on the end. The reason it's angled down like that, I think I'm going to chalk up to the probe that we were using. It's kind of hard to keep it steady at all times on there. So just in this capture, it just happened to be sloping. Got a little bit of a wave going on there, but it is straight. The firing line, spark line is pretty straight there, right? And then I just wanted to show an example of a multi-strike ignition. So this is on a Ford Edge, and we can see we have multiple strikes going on inside that ignition event. So this was at an idle. We have multiple firing events going on there. So now let's talk live on the tool. All right. So I'm checking. Zoom doesn't look like we have anything in the Q&A quite yet. So if you do have any questions throughout, make sure you put them in the Q&A if you're on Zoom. If you're on YouTube, definitely utilize that live chat function as well. And we'll get to any and all questions at the end of the course. So as far as testing ignition with the tool, as I said, any of our tools that have at least a scope or got a component test in there, which they'd have both. The easiest way to test single cylinder ignition, the one that everybody could do, would be to use a guided component test. So let's go into guided component test and load our vehicle. Now, if you've been to any of our other classes before, you'll know that this is VIN-specific, vehicle-specific information in here. There's over 5 million tests available inside guided component test. Goes all the way back to 1981 and covers 28 different makes. So I bet you'll be able to find ignition on most of your popular vehicles in here. Now, once we load into a vehicle, as I said, VIN-specific, it brings up our different categories of systems that we could test. So in this case, I'm going to test engine. Once we load into that, we will see different components we can test or subsystems in there as well. So in this case, I want to do an ignition test because that's where my ignition tests are. So we could do component information, tells us all about the ignition system. Primary tests will tell us about the primary side. We spent a lot of time talking about secondary tests, so let's take a look at that and do a secondary ignition test. So in this case, on this vehicle, it is a coil near plug system. So it has individual coils for each cylinder, and it has a short spark plug wire that goes between the coil and the spark plug. So in that case, we can test each individual spark plug wire or hook up to all spark plug wires if we wish to do so. So it tells us how to hook up. Also tell us sweep, scale, and delay may need to be adjusted depending on the RPM. And then if we go down here, it gives us a known good pattern, and there's our known good ignition pattern. So by hitting view meter, I will go to my home screen and load out of what I was looking at in the last class. Okay, there we go. So there is my meter. Let me close out of this here. Just back up one, go back in there. Here we go, view meter. Okay, so when we hit view meter, it'll automatically set the voltage, automatically sets the time where it needs to be. All right, so I do see an ignition pattern on here. Looks like I'm looking at about 20,000 volts range and about 10 milliseconds in time. So that's a pretty good place to start. Looks like it is moving around quite a bit on here, and I want to kind of lock that in place. So the one thing it hasn't done for us is turn on our little trigger point, which is allows us to lock the pattern in place. So if I go over here, I can turn on my trigger. So that's slope right here would be to turn on the trigger. So if I click on that, it turns on my trigger point, which it's indicated to me is over here to the left. Drag that up, put it somewhere in the pattern, and it will catch that pattern when it goes across the screen. Anytime that voltage range crosses that plus sign, it'll hold it in place and freeze it on the screen. Now I do have a little bit of negative voltage going here, so I'll just lift it up. And there we go. So I can see dwell, firing line, spark line, and then my recovery oscillations there. So that is single cylinder ignition testing. And like I said, very easy to do if we use the guided component testing. So now let's talk about ignition scope. So to do that, if you have a Veris or a Zeus, you can go into where it says scope multimeter. And then we see we have the lab scope, and then we have the ignition scope. So this is a true ignition scope that we can use to check our parade pattern, our raster pattern, etc. So you see it gives us patterns to start with. So we could do single cylinder ignition. That's like what we just did on the previous screen. So I'm going to start with parade. So we click on parade, it'll set it up for us, and we will see what we see on the screen. Now, in this case, on my tool, it was already set up because we did this before. But on your tool, if you've never been in here before, you may need to do some setup functions because it defaults to different settings than what you might be used to. So to change my settings on my ignition scope, I can go up to setup, and then I can go to setup again because I want to set up my ignition. Once we've done that, it defaults to wave spark, right? So you'd have a look kind of like this. It looks a little bit different. That's that positive and negative polarity. So I'm going to set it to standard, and that way we can see standard ignition. We can also change the number of cylinders, anywhere from 1 to 12. When you're on any of these pop-up windows, just FYI, you want to hit the back button, not the exit button. If you hit the exit button, it closes all the options down. You have to click back in to get there. If we hit back, it just closes that one window. We can also set the firing order. So I just set it to 1843657 That's small block Chevy, right? Hit back. Then we can tell it where it's triggering number 1. So we trigger it off the plug. So you can put it on the plug wire, that RPM pickup, right? That inductive sync clamp. I can plug it on there. Because we've told the tool how many cylinders it has, and it sees every time it sees a firing event, it calculates the RPM for us as well. Hit exit. And there are my signals. I'd be connected to all cylinders at the same time. And then my firing orders here across the bottom. So 1, 8, 4, 3, 6, 5, 7, 2. Right, then I can see what cylinder is one higher, is one lower, is one missing. What do I have going on there? So that's parade. Next one I'd like to talk about is cylinder. So this is a single cylinder on the screen, and it's similar to what we were looking at before with the single cylinder ignition. The difference is, in this case, we would already be connected to all cylinders at the same time. This allows us to cycle through all cylinders and just see one on the screen at a time, but still be connected to all of them. You see the difference between the two is this little triangle right here. So this triangle is my trigger point. Remember on the single cylinder ignition test that we did, it had a plus sign as a trigger point. So in this case, this is our vertical. We can only go vertically, and it's only where it crosses. Also, good suggestion for if you are doing an ignition test with one of these tools and you're having trouble getting a pattern, check where this trigger is. If it's too high, you'll just have a blank screen like that. Right? If the voltage never crosses where this triangle is, you won't see a pattern. So it only draws a pattern from where that is. If I bring it down about here, now it crosses the pattern, and now we can see it on the screen. Now, how do I cycle through my individual cylinders? If I go down here on the bottom right-hand side, we have this little picture of a clamp. And then it gives us an option to trigger off of whatever cylinder we're using. So cylinder 1, cylinder 2, cylinder 3, cylinder 4. You won't see any difference on this screen because it's just the simulator puts out the same signal every time. But on a real-life car, you can see the difference between cylinders. So that is cylinder. And then last one we'll talk about is raster. So raster is that stacked on top of each other look, right? So we have our firing lines all stacked up on the left. Our spark lines come out here Is one higher, one lower? Do we have that weird ramp at the end where it's showing lean? What is going on with our cylinder? Now you may think, in this case, they all look pretty even. They're spaced okay. But on a real life car, maybe you have a lot of ups and downs and all arounds going on, and it might be a little more confusing to see what's going on. Maybe I'd like to space them a little further apart. Well, in order to do that, we'd go up to the top where it says setup. We go to traces and trace 1 because that's our yellow channel. And then we see in the middle, we have our raster spacing slider. So we slide it up and down, and you can see what goes on with the pattern in the background there as we do that. If you bring it all the way down to bottom, you actually get a superimposed pattern where they're not spaced out at all. All right, so we have that right there. Okay, and one more thing in here that's kind of a hidden gem. We've had this function for a while, so we kind of hid it in there, and a few folks have asked, hey, how do I find that? I used to have this on my whatever other machine they used to have. And so, well, it's still in there. So let's find it. So we go up to setup, and we go to view, and then we go to display. We want to display this. And then we see show digital KV here. If I turn that on, this shows me a numerical representation of what's going on the screen. Some people like to see the numbers versus seeing the picture on the screen. So I can see my minimum, maximum, and actual of what the firing line is doing. How high is that voltage? Spark line, where does that spark line come out? And then what's my burn time on my cylinder? So you can see numerically, how do they compare with each other? I think, if you had some sort of a running problem, you could actually print this out. You could show it to a customer, say, hey, your firing line's too high on this side, or your burn time's not long enough. Maybe we need to do a tune-up. I also think to performance shops, right? Maybe a performance shop might want to do a report on an engine that they do to make sure that they're getting as close as they can with performance, burn time, and such on their engines. So might be a good idea for that as well. I'm going to turn this off, because it'll come back in here next time we come in here. So let's hit setup, view, display, uncheck the box, and that brings us back to where we were. A couple other options while we're in here. We also have a show RPM checkbox, so that just brings the RPM up on the screen. We can turn that on or off. Show the grid turns on the grid lines. Some people like to have the grid lines just so they can eyeball what's going on the screen. And then invert colors is good for, say, printing. If I wanted to take a screenshot of this and then print it out, having it inverted, I don't have to use as much black ink in that case, right? So that is Ignition. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully we'll see you next week. Hopefully you can watch and see you on any of our other videos. Have a good week, have a good night, and take care.